Professor Lal is a distinguished professor of soil science, director of Carbon Management and Sequestration Center, and president of the International Union of Soil Science. He's also adjunct professor, University of Iceland, the Ohio State University, Columbus. So the presentation of Professor Lal is soils and world food security.
Thank you. Thanks so much. I think that was my presentation in the morning. Now I think it's soil health and sustainability, but it's kind of continuation of the same thing. Anyway, thank you so much, especially for agreeing to be the chair of this session, and thank you for coming here. We're going to continue where I had left this morning. I want to define first what soil health is. It's a journey and not a destination. And the reason I say it's a journey because the need of soil health and what it requires to achieve keeps changing with every generation. It's not a static concept. It's very dynamic. It depends on what is required at that point in time. And from that point of view, I would like to take you back in relation to the destination of soil health, changing with every generation. And I picked up a Bible to see what Bible had to say on this concept. And I'll go through this similar thing about Buddhism and Hinduism, just to pick up three philosophical concepts, how they say. So the Bible depicts Moses stating around circa 1400 BC as they entered Canaan. I don't need to say what Canaan had implied. And he said, "See what the land is like, and whether the people who live there are strong or weak, few or many. What kind of land do they live in? Is it good or bad? How is the soil? Is it fertile or poor? Are there trees on it or not? Do your best to bring some fruit of the land." I cannot say anything better than what the need of soil health was 1400 BC. And the reference is given here, and that's as specific as it can be. So that gave me thought, maybe some others ancient civilization had something similar to say. By the way, if you want to read something more about it, Breivik and Sauer quoted this in their recent article. So I looked up soil health in the ancient cultures, and I went back to Asia and looked at the Indus Valley civilization of the Harappan culture, the so-called Aryan, Indo-Aryan. And Chanakya, I do not know how many of you would ever know who Chanakya was. He was the kind of secretary of revenue of the Maurya kingdom, from which Ashoka came, the biggest emperor of his time, uniting the South Asia all the way from Afghanistan to Sri Lanka at one time. And he wrote a book in Arthashastra. Arth means economics, Shastra means science, science of economics. That's a book. Actually, I have a translated copy of that, both in Sanskrit and in English. And he explains manuring and systems of soil fertility management and water conservation strictly to increase the revenue of the emperors from agriculture. So his interest was how to manage soil. And I thought Chinese must have something. And of course, sure, Xi Jing, 770 to 476 BC, in the Book of Odes, explains agricultural practices dating back to Zhou dynasty to improve soil productivity and soil health. So a compilation of 305 poems, of many of which are actually devoted to soil quality and health issues. So yes, the ancient cultures and philosophy and religion certainly had this, and I gave more details in the article I wrote on the societal value of soil and soil carbon. Then I thought maybe there must be something from the Arabic world. Sure enough, there's a book called Kitab al-Falaha. Those of you who understand Arabic or even Urdu, Kitab means book, Falaha means agriculture. It's a book on agriculture. And it was written in 11th somewhere by Ibn al-Awan. And Ibn al-Awan was a Moorish You know who the Moors were? Philosopher in the Spain around the Cordoba area. In fact, I have seen some of the work of that time in the city of Cordoba, and the book on the 12th century, and very nicely predicted, said, the first step in the science of agriculture is the recognition of soils and how to distinguish that which is of good quality and that which is of inferior quality. He who does not possess this knowledge lacks the first principle and deserves to be regarded as ignorant. I tell my students, read it. Just make sure you are not ignorant. How, and I think I must say we have quite a lot of ignorance in 7.5 billion people at the moment. But that's as specific. And the next part of what he said, I got a copy of this book translated in French from Christian Feller. Many of you may know from Montpellier, Christian Feller, who deals with interest in historic issues. But the next part, which he says, one must also take into consideration the depth of the soil, for it often happens that its surface layer may be black. You understand what that implies and indicates, meaning there was a soil organic matter and humus. So how specific can it be? There was a symposium held in Spain, Valencia, in the city of Valencia, maybe about 10 years ago, and the speaker before me said in 1997, John Duran from USDA, Steve, you know, John Duran, first defined soil science, and I was the next speaker, and I had this picture from Lama on the board. So we had quite a few discussion on that thing. I did not have Moses' concept on there either. So I think what I'm trying to say is the questions have remained the same ever since the settlement of agriculture. Is the system sustainable? Is the soil health manageable? What has changed over 10,000 years is not the question, but the answers to those questions. That is what has changed, because our demands, our needs, our scientific knowledge keeps changing. And that's why every generation has to keep repeating that question, because the answer is different because of our demands and because of our... So I just wanted to let you know that this was a continuous saga, and every generation has to answer, get their own wheel, so to say. So soil health and soil quality are the two other concepts Steve and I talked about last evening. We want to make sure there is a distinction between the two. The continued capacity of a soil to function as a vital living system within ecosystem and land use boundaries to sustain, and the next line gives you the ecosystem services, biological productivity, maintain the quality of air and water environment, and promote plant, animal, and human health. These are the ecosystem services which the soil as a vital living entity would give in terms of, and that was John Duran. I tried to read that several times to see what are the ecosystem services that John and his colleague mentioned: biological productivity, quality of air and water, promote plant and animal health. I guess you could relate quality of air to climate change, but in 1994, 5 and 6, when that Committee of Soil Science Society of America was established with John Duran and other, I think climate was not yet an issue. So I thought that part was ignored, overlooked, because it was not really a problem. The more problem was water quality, air quality, but air quality from many other point of view, productivity, that was the issue. So I think that part was left out, at least in that definition. So another part issue these days is micronutrient efficiency from the nutrition point of view, human nutrition. This morning we were talking about, and yesterday, 2 billion people suffering from hidden hunger, which is the deficiency of micronutrients and protein and vitamins and so forth. So the issue comes in, how does the health effects of micronutrients, children especially vulnerable to deficiency in zinc, iron, causing anemia, young mothers and children, very, very serious issue globally. 17 micronutrients, I listed them here, which are essential. They must come from soil because that's the source where these micronutrients must be available. 7 are the major micronutrients which must also be supplied by the soil. So in many respects, these nutrients, soil must have a both capacity and intensity, that those nutrients are available at sufficient amount at the right time where they can go into the parts which are edible and at the same time available. And I think this is a very important phrase I want to mention, and I'll also give you the history where it came from. The health of soil, plants, animals, people, and ecosystem is one and indivisible. That's a very important part to understand. The ecosystem part I have added, but the other part came from Sir Albert Howard, or Sir Howard. He was a medical doctor working in India in the 20s and 30s as advisor to the British government in the state of Madhya Pradesh, in a city of Indore, of all the places. And there he realized that the peasant farmers whose soil did not have enough organic matter were really suffering tremendously from health issues related to these. And as a president of the Science Academy of India at that time, this was the title of his lecture in 30s, indicating soil health. And he developed a system of manuring compost, developing compost from animal and human waste in a kind of a pit which is called indoor pit. It's misspelled because people do not realize sometimes Indore is a city, so they think it's an indoor pit. No, it's an indoor pit. And the idea was to raise the temperature of the decomposing media to more than 60 so that the microbes are destroyed. And he detailed it as a medical doctor very specifically. And this statement, the health of soil, plants, animal, people, and ecosystem is one and indivisible, is very profound statement from the policy point of view. You cannot, I think in 1938, the president of the Soil Society of America, William Albrecht, he came up back with a similar concept. You cannot maintain the health of a society until the health of the soil is maintained. A very important concept. So comparing the distinction between soil quality and soil health, then I think the term soil quality and functionality, by the way, in Europe, EU, soil quality is not kind of very much liked. They like to use the word soil functionality, but they're not synonymous to soil health. I think that's the point I'd like to make. And they should not be used interchangeably. Soil quality is related to soil functions or what it does, whereas soil health presents the soil as a finite and dynamic living resource. The living part, which is microbes and earthworms and termites and soil biota, their species diversity, and that is what is related to soil health and plant health part, which is kind of a distinction. So soil functionality is the capacity of the soil to perform several functions. And what are the functions? Production of biomass, moderation of climate, cycling of elements, decomposition of waste, renewal and purification of water, providing habitat for biodiversity, creating media for plant growth, and of course being a foundation for civil structure and source of archive of human and planetary and paleoclimate history. These are several of the functions of the soil which are very important, very, very numerous, not just the plant part. And these functions are sometimes difficult to quantify. And that part is also important. How do you quantify these functions? Therefore, they are indirectly estimated through a soil quality index. And that part, why the soil quality and what parameters should be represented, will depend upon what functions you are addressing. Or in other words, what land use you are addressing, which would be then the soil quality index. So I think some of you may recognize Edward Deming, who was a business specialist. And he wrote, and I think that quotation is misquoted many times. Sometimes people say you cannot monitor something that you cannot quantify. But what he said was that things cannot be measured quantified, must be managed. He was a businessman, essentially saying if you cannot measure it, make sure it's measured properly. So with that background, and talking about soil functionality and soil health, the question is not what is there in the soil that can be measured, quantified, but what it does must be quantified. So what it does part becomes more important. And what it does is soil quality and functionality. I think that's the concept which is quite important to understand. What soil does is something that needs to be quantified. I want to also relate soil organic carbon effects on soil quality and health. So here is a soil organic carbon in terms of its quality, quantity, dynamics. And on the one side of that, we have a soil quality, which means fitness for use, which means capacity to function, and therefore those functions which I just described you few minutes ago, soil functionality related to soil organ. And the other side of that is the soil health, and that the capacity of a soil as a vital living system that affects health of plants and animals that live on it. There's a subtle difference. They are not the same thing. And therefore that part becomes, this link and understanding from the soil point of view and the soil management point of view, that's where soil microbiology work, both of my other colleagues on the panel look at that right side of things is a very, very critical, very important part to understand. So in that point of view, I thought I will give an attempt to defining soil health. It's a soil's capacity as a dynamic and biologically active entity. When a soil is dead, it's obviously not soil anymore. It has to be biologically very dynamic, and within both natural and managed landscape, to sustain multiple ecosystem services. And then I listed what they are: net primary productivity, food and nutritional security. Remember those microelements are biodiversity, water purification, renewability, carbon sequestration, that's related to climate change, and of course atmospheric chemistry and elemental cycling for human well-being and nature conservancy. This little difference than what John Duran had. He did not specifically have the climate part and carbon sequestration and human part. So I think it's a slight difference than what he said, but there is definitely an important difference, such as soil carbon sequestration, water renewability part. Renewable part of the water is an important component, which I included in a publication which is probably just going to come out next week or so. So what are the technological options of soil carbon sequestration? There is a range of them. The idea is to create a positive soil carbon budget, which I explained this morning as well. And there are a range of practices: conservation agriculture, no-till, residue mulch, integrated nutrient management, cover cropping, all come under the overall concept, overall umbrella of conservation agriculture. Then, of course, we have complex farming systems, whether it is the integration of crops with livestock, with trees, urban ecosystems. I mentioned this morning is very critical, with 70% of the global population living in urban ecosystem by 2050. And then, of course, the biofuel plantation integrating within the crop. So mixed systems. Somebody asked me a question, why animals are no longer? Well, animals need to be looked after 24 hours a day and 7 days a week. Therefore, people who want to do something different cannot do that always. And that's a social issue, which is very important to address. Restoration of degraded lands, eroded landscapes, salinized lands, mined lands. Ohio's being a mining state along with our adjacent neighboring states, that's a very important issue. Depleted lands, land which are depleted, how do you improve the soil health through increasing a positive carbon budget? And then, of course, the organic amendment. I mentioned Albert Howard, his compost system, manuring, biochar, vermiculture, and of course the interconnectedness through organic agriculture, ecological restoration, farmscaping, agroforestry, many combinations. The site specificity and fine-tuning of those, of course, depends on site to site. Drought of 2012 in the Midwest, Ohio was not very seriously affected, but we were affected. Western part of the Midwest were affected more, such as Kansas and other regions. Texas obviously suffered much longer, and so did California. But drought is an important issue, and I want to take a few minutes. How would soil health address the drought part? I had a graduate student, Josh Benisson, 6'4", and tall, just to tell you how this garden is. This experiment was at Coshocton, Ohio. Continuous conservation agriculture with crop residue mulch since mid-70s. This picture was taken, I think, 2012. It's 2012 drought, right up, they say. And what we did was, as part of the state panel, 10 states have the same experiment related to biofuel from crop residue. Take away crop residue completely, 100%, 50%, 75%, 25%, and so forth. So here is a no-till plot since mid-70s. We took away the crop residue, and then we came up with the drought. And plot 2 meters away is the one where the crop residue was left on. And this was after 4 years. So this morning I showed a picture from Africa with a similar example. And subsequently, with good rainfall, including last year, we did not see these dramatic differences. So a drought where the water holding became important, where the runoff on a sloping land was an issue, where evaporation and the temperature, heat wave are issues. These two plots, few meters apart, same date of planting, same everything. Josh, as I mentioned, 6'4", you can see, I do not need to tell you what the yield differences were. They were 60% different. So if somebody asks me, what is climate resilient agriculture, or what is a drought tolerant maize, that's it. You're looking at it. Management. It's not what you grow, how you grow it, how you manage the soil, how do you manage the microbial processes, the earthworm, especially the earthworm population. Soil temperature was 10 degrees centigrade in the hotter part of the day, cooler under mulch than, of course, under without mulch. That makes a big difference. That has a tremendous impact on soil health and resilience. So what are the soil health and ecosystem services, which are very important? Plant nutrients, nutrient cycling, nutrient retention, elemental transformation, nutrient delivery to plants as a medium of plant growth and physical support, water purification, filtering of water, storing water for plant use, which I showed in the print, denaturing the pollutants, climate moderation, carbon sequestration, emission of N2O, CH4, and of course CO2. Many times people say we want to stop CO2 emission. Gee, that's the same thing like I stop breathing out, you know what that means. So you don't want to kill soil. A healthy soil must breathe. It's not a stop emission of CO2, it's you want to make sure that carbon biomass added into the soil is more than the respiration needs and the erosion and mineralization losses. So we do not want a soil to stop breathing. That would be end of it. Biodiversity is important, conservation, habitat, waste disposal, that spelling there, which I didn't check, and of course, reservoir for germplasm, some of the important services related to soil, carbon. I learned last year in Windsor, Canada. I was a speaker at one of the, and the meeting was not by soil scientists or agriculturists, it was actually by pharmacists. And that's where I learned that 90% of the antibiotics come from soils, the microbes which are in soils. So that disease suppressive soil, special organisms in soil that suppress pathogens, and many issues in terms of the climate change, especially. We want to make soil and agriculture as a solution to the problem of climate. Right now, the way agriculture is, we must produce food, and at the same time, we must minimize the environmental footprint, and both of those can be at odds at one another. The question is how to synchronize, how to make soil and agriculture as a solution to the environment problem, not as a problem. And I think that approach, making it a solution, and some people say, why it has to be solution? Well, because we eat food 3 times a day. If you decide not to eat food and make it a public, that's a different story. I'll listen to you carefully, but otherwise we have a responsibility to make sure that soil and agriculture are a solution to this issue, and that has to be the case. So here are ecosystem services, soil health in the middle, water resources, quality and quantity, climate change, mitigation, adaptation, stabilization, food security, nutritional security, both quantity and quality, biodiversity. The engine of this is soil health. Soil health drives those forces, and that's the part which is important. That's what the soil health does, and we want to make sure, because that's also the engine of economic development, also the engine of political stability, and that part is important. I think I'm coming to the close and want to show you how I visualize soil looking at the ecosystem function. Here is a pyramid, and remember those pyramids in Egypt. So think about a base of pyramid, and it has 4 sides. So the base of the pyramid is really the soil resource, the carbon pool, the soil health part. That's the base, that's the foundation. That's on which everything else depends. And what are the other 4 sides? Well, food security. Nutritional security is one of the sides. The second side is climate change adaptation and mitigation. The third side is land and soil restoration. The fourth side is biodiversity of the soil. So the pyramid has those different components and the foundation of that. Now, as you know, this pyramid cannot be stable. It cannot stand. Its strength really depends on the 4 corners where all those 4 sides join together. And somewhere those 4 sides have to be cemented together with a glue that they do not fall apart. And I, as a soil scientist, strongly believe that glue is the political decision and policy. That's where we need good policymakers. We really cannot make progress without having policy people with us, listening to us, and we listening to them to make sure that whatever we want, we communicate to them properly and say, without you, we cannot have that success. There's no way. In fact, there are examples where it does not happen. And this political stability and peace, that's the policy, the environment, making sure that the right things are available to decision maker is very, very critical in relation to soil health. So I also wanted to put in terms of a perspective, and the reason was you hear a global icon, a panda or a bald eagle or many other things you notice given the icon of environment and health. I think the real icon should be a soil, a healthy soil, a soil which can support above ground and below ground a healthy plant growth with root biomass of different things. It should have biopore and channel. It should have soil biota, organism that you can see and organism that you cannot see, and those which can burrow the channels and then make biopore and root and the earthworms and termites and centipedes and millipedes. You don't want to kill those organisms. They must breathe, they must eat. They are the one which makes soil as a living entity. That's what the soil health is all about. And then, of course, the important part is, I remember this morning I had a cycle of water, carbon, nitrogen, phosphorus, sulfur. These things have to be recycled. You take a biomass and recycle it, and that recycling of all these together on a continuous basis is critical. This is where the death becomes life. A soil has the power, divine power if you want to call it, to convert death into life, through transformation, through biochemical cycle. So as a president representing 60,000 soil scientists around the world, I would say soil is life. There is no other one. And if there is any God, and I don't mean to offend any religion, that's it. You're looking at it. Thank you.